Today we're going to go over what's called L'Hopital's rule. It's another way to do limits. Yes, we're going to revisit limits from the beginning of the year. Good time to reconnect with them. The types that I'm going to do with you are the indeterminate forms of 0 over 0 and different infinities over infinity, so plus or minus infinity over infinity. We're going to go back to the beginning of the year to start our discussion with one that hopefully you remember. The limit as x goes to 0 of sine of x over x. I'll give you a minute to think about that one's answer because maybe you remember it from the beginning of the year. And hopefully you have that answer in your brain. If you're thinking what I'm thinking, you're thinking it's 1. Yes! All right, so then what L'Hopital said is that to do a limit of an indeterminate form, first we analyze to make sure I can use L'Hopital's rule. I evaluate the numerator and the denominator separately to see if it matches this. So you have to write out each of your limits of the numerator and the denominator. So I'm going to say the limit as x goes to 0 of sine of x is equal to 0. We know that using our pre-calc skills. The limit as x goes to 0 of the function x also goes to 0. Now because that matches the form 0 over 0, I am allowed to use L'Hopital's rule. What L'Hopital's rule is you go to any quotient that you have and you simply take the derivative of each, the derivative of the numerator, the derivative of the denominator, and you reevaluate it. So the limit of x approaching 0 of sine of x over x goes to the limit of cosine x over 1 because I'm simply taking derivative of the top divided by the derivative of the bottom. Then you analyze that end limit. Well, what is the cosine of 0? The cosine of 0 is 1. So yes, we got that answer we were thinking about a long time ago. So here's L'Hopital. L'Hopital says the limit as x approaches whatever we have for our input, function f over function g. That's going to be equal to, as long as it's that indeterminate form, the limit as x approaches, same thing, but then it will be f prime of x over g prime of x. And that's L'Hopital's rule in action. Our next example is the limit as x goes to infinity of the natural log of x over 4 square roots of x. We're going to start off, evaluate each, the numerator and the denominator. As you go to infinity, where's the natural log curve heading towards? Everybody's hopefully saying infinity. Square root function times 4 is heading towards, wait for it, infinity. So we have that indeterminate form, infinity over infinity. I'm okay to come back and now use L'Hopital's rule. L'Hopital says I take the derivative of each. The derivative of the natural log function is 1 over x. The derivative of the 4 square roots of x is 2 over the square root of x. All right? And then if I look at it, I'm like, well, I can do some algebra to this thing so that I can evaluate it before I go any further. And what algebra skills do I have to implement? Well, 1 over x divided by another fraction is the same as multiplying by its reciprocal. So I'm going to flip it to root x over 2x using my algebra skills. And I'm thinking to myself, well, I can still do more algebra to this thing. If I root x divided by x, that's the same base. I just have to subtract my powers. I end up with 1 over 2 square roots of x. So then when I go to evaluate this limit now, as I approach infinity, it becomes 1 over something that gets very, very large. 1 over something that gets very, very large, overall gets very, very small. So the limit of this is approaching 0. Example number 3. I have the limit as x goes to 0, my square root of 1 plus x minus the constant 1 minus x over 2 divided by x squared. I can see my numerator goes to 0, the denominator goes to 0, so I have that indeterminate form of 0 over 0. I apply then L'Hopital's rule, so the derivative of the square root function becomes this piece right here. The 1 goes to 0, the derivative of x over 2 is a half. The derivative of the denominator is 2x. Well, if I look at this, again, if I plug in the 0, I have a half minus a half. So the limit of the numerator is going to 0. The denominator is going to 0. Guess what? I'm going to apply L'Hopital's rule again. You can apply L'Hopital's rule as many times as you need to, as long as you keep getting that indeterminate form of 0 over 0 or plus or minus infinity over infinity. So here's the derivative one more time, and I know it's going to work this time because I'm seeing a 2 in the denominator, so that's a constant. So I'm definitely not dividing by 0 or by infinity. And then the numerator, the derivative goes to a quarter times 1 plus x to the negative 3/2. And then I plug in my 0. I have my 1/4 times, plug in the 0 here, that's 1 to any power. 1 to any power is just a 1 divided by a 2. If I take a fourth divided by 2, that's going to give me an answer of 1/8 for my limit. That's it for my presentation on L'Hopital.